Pleasant morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. In today's session, we are going to discuss about the deep learning architecture of the application autoencoder. That was today's session. So the autoencoder, or the type of artificial neural network used for unsupervised learning. They work by learning to encode the input data into a lower dimensional representation and then decoding it back to the original input. This process aims to capture the most important feature of the input data in an encoded representation. The encoder consists of an encoder network that maps the input to a hidden representation and the decoder network that constructs the input from the hidden representation. They have the various applications in deep learning, including an image denoisation, anomaly detection, dimensional reduction, learning features, and natural language processing and recommendation system. We have a various types of autoencoders like vanilla autoencoders, sparse autoencoders, and denoising encoders, variational encoders, convolutional encoders, and so on. When we have a vanilla encoder which knows that it is fully connected autoencoder, we consist of fully connected layers in both the encoders and the decoders. And the vanilla encoders are the simplest form of autoencoders and can be used for the various tasks such as dimensional reductions and the feature learning. The phrase autoencoder. In phrase autoencoder, the sparsity constraint is added to the hidden layer activation. This encourages the autoencoder to learn a compact representation of the input data, which can be used for a task like anomaly detections and the features learning. When we have a denoising encoders are trying to remove the noise from the input data by corrupting the input and reconstructing the original clean data. They are the effective for the task like image denoising and can be learned robust representation that captures the underlying structure of the data. And the variation encoder autoencoders or the probabilistic encoders that learn the latest variable model of the data. They aims to model the underlying probability distributions of the data and can generate a new data samples and widely used in a generative modeling and so on. As the last autoencoder is a convolutional autoencoders, here the encoders and the decoders network, making them well suited for processing high dimensional data such as image. They perceive the spatial informations and are commonly used for tasks like image denoising, reconstructions, and feature extraction. When we move on to uh, the applications of autoencoders of image denoising, the denoising autoencoders are effective for removing the noise from images by training on noisy images and their clean counterpart. Denoising autoencoders learn to construct the original noise-free images. This capability is available in various domains, including a medical imaging, satellite imaging, and surveillance. And anomaly detection is all about the autoencoders can be used for anomaly detection by learning to construct a normal insistence of data. During training, the autoencoder learns to reconstruct the input data accurately. However, when presented with anomalous data, the reconstruction error is higher, indicating the presence of anomalies. This approach is used for cybersecurity, fraud detection, and fault tolerance detections in industrial systems. And when we have a dimensional reduction, these autoencoders are capable of learning a compact representations of high dimensional data. By reducing the dimensional of the input data, the autoencoders can capture the most salient features while discarding a redundant information. This is beneficial for the tasks such as visualization, clustering, and data compressing. When we have a feature learning, the autoencoders can automatically learn a meaningful features from a raw data without the need for the manual feature engineering. By training on unlabeled data, the autoencoders learn to construct the relevant features that captures underlying structure of the data. These learned features can be used for the other classifications and so on. The natural language processing is where it is used such as text generation, text summarization and language translations. And the recommendation system is just a crucial part in recommendation by learning your low dimensional representation of user and the items. I hope you were clear with this applications of autoencoders. Thank you.